Hi everyone. Now we are going to look at the question number 5 of IITM-Es graded assignment 4 ESTC. Right. Here, let's look at the question very carefully. So they have given R1 equal to R2 is equal to 2 kilo ohm, R3 equal to R4 equal to 2 times R1. So 2 times R1 is 2, therefore it is 4 kilo ohm, and R5 equal to R6 is equal to 0.5 times 4, which is equal to 2 kilo ohm. Alright. So here, if you look at this R1 and R2, both of them are here 2 kilo ohm, and R3 and R4 here also 4 kilo ohm, both are of same values, and R5 and R6 again 2 kilo ohm. Alright, so now what we are going to do is, now we are going to remodify the diagram. First, this R1 and R2, we already know for the resistors in parallel connection R1 into R2 by R1 plus R2. So in this formula, if you substitute the values of R1 and R2, you will be getting the value of Rp. But one more shortcut trick is there. That is similarly, these two values are of equal. Hence, what we are going to do is blindly, since 2 and 2 both are common, so 2 divided by 2, how much it will be coming? It will be coming as 1. So this diagram, we are going to modify it again. So this shortcut trick is applicable only for the parallel resistors of same values. So if you look at the R3 and R4, so R3 and R4, if you're looking, so the parallel connection for this 4 is the common value. So 4 divided by 2, 2. And similarly R5 and R6, here 2 is the common value. Therefore 2 divided by 2, 1. Got it? Now, here we're going to remodify the diagram. As I already said, so this diagram, in the place of R1 and R2, 2 is a common one, so 2 divided by 2, it is 1 kilo ohm. Okay, so that one got finished. Now, modifying the diagram again, here, so 1 kilo ohm it came. Next, going further, so now going further, what we are going to do is here, that is this R3, R4 values are there. Let us draw as it is. So this is R3, which is 4 kilo ohm. Again R4. So again R4, which is also 4 kilo ohm. Okay. So these parallel resistors I have drawn here now. Now this R5 and R6 resistors are there now. That one we are going to remodify it again. So here, if you look at it very closely here, the term, excuse me. So wait for a while. Yeah. So here R4 and R5 values are there, right? So this R3 and R4 we already written example, sorry, R5 and R6. So this R5 value we are going to draw in the parallel. So R5 it is here, then again R6. So R5 and R6 here both are 2, here also both are 2. Alright, now here the terminal B is there, now we are going to join with all the resistors. So that is all. Now, how we can solve this? We already know this R1 is R1 parallel to R2, that only we got 1 kilo ohm. So the shortcut trick for this is the resistors in the parallel connection. So what the shortcut trick is R1 is parallel to R2 plus, okay, here this R1 parallel to R2 we got it as 1 kilo ohm. So now we are going to add all these resistors R3, R4, R5 and R6. Okay, so already we know R3 and R4 both are of same values 4 kilo ohm. Hence R3 parallel to R4, which is in turn parallel to R5 parallel R6. That is all. Okay, fine. Now let us substitute the values. Already we know R1 parallel to R2 1 kilo ohm. Okay, so 1 kilo ohm unit also I am writing plus R3 parallel to R4. So if you look at this, R3 parallel to R4, here R3 and R4 both are of same values 4 kilo ohm. I already said the shortcut trick. If the resistors are parallel with equal values, you blindly divide by 2. Since 4 is the common value, here 4 divided by 2, it is 2. 2 which is parallel to R5 parallel to R6. Here R5 and R6 both values common, which is 2. So 2 divided by 2, 1. Okay, fine. Now solving further, already we solved 1 kilo ohm plus, here 2 is parallel to 1, here 2 is parallel to 1. So 2 parallel to 1, since both of them are different values, so just write that parallel formula, R1 into R2 plus divided by R1 plus R2. Okay, so therefore 1 kilo ohm plus 2 into 1 is 2 divided by 3. Okay, so solving furthermore, we will be getting it as 1 kilo ohm by plus 1 divided by 3, 0.33. So 2 into 0.33. So 2 into 0.333 kilo ohm, 1 kilo ohm plus 0.666, it will be gone. So we can round it up to 67 cumulatively. So final answer will be getting it as 1 plus 0.67, 1.67 kilo ohm. Alright.